table shows some information about the heights in centimetres of some tomato plants in Maggie's garden, and I need to draw a box plot for this information. So I'm first going to draw a line at 12 for the minimum. Then I'm going to draw a line at 27 for the lower quartile, a line at 35 for the median, a line at 42 for the upper quartile, and a line at 55 for the median, for the maximum, sorry. And then I'm going to join those up to form a box plot. Then we are told that there are also some plants in Nigel's garden. The box plot shows the distribution of the heights of Nigel's tomato plants. And I need to compare the distributions of Maggie's plants at the top here and Nigel's plants at the bottom. So first of all, let's compare their medians, the average size of their tomatoes plants. I can see that the median for Maggie is 35, the median for Nigel is only 25, which means that Maggie's plants are heavier on average. So the sentence that we're going to write here is that Maggie's plants are heavier or are bigger on average because they have a higher median. Right, the next thing we're going to compare is the interquartile range so that we can see how consistent they are. So let's do that for Maggie first of all. Her interquartile range is the upper quartile take away the lower quartile. So 42 take away 27, which is 15. Nigel's interquartile range, well, just by looking at Nigel's, I can see that his interquartile range is bigger there. What's that, 24, I think? If I do 40, take away 16. So Nigel's got a bigger interquartile range, which means that they're more spread out. They are less consistent. So I'm going to say that Maggie's plants are more consistent. Because they have a smaller interquartile range. And we're done. Always those two sentences.